Hello my dear students, welcome in our discussion for today, and hopefully you learn from our discussion for today. Please stay with me until the end of this video. So in today's lesson, we are focused on quadratic equations. In today's lesson, we will illustrate quadratic equations. We will also solve quadratic equations using factoring method. Within the discussion, we shall be answering questions such as, when do we say that an equation is quadratic? How do we identify the values of A, B, and C in the general form of a quadratic equation? What are the different ways of solving quadratic equations? In this number 3, we will not focus on all the different ways. Instead, we will just choose one, because if ever we will deal with the different ways, then we will have a limited time. So we will take just one, then the rest of the different ways will be discussed later. Let's start with the definition of a quadratic equation. A quadratic equation is a polynomial equation of second degree. Take note it is second degree. Some examples are the following. For example, I have x squared negative 2x positive 5 equals 0. I can also have x squared positive 5 is equals to 0. Or I can have 6x squared equals 0. In number 1, you would notice that in the left side of the equation, you have 3 terms. While in number 2, you have 2 terms. In number 3, you have only 1 term. But in all of these 3 equations, there is one common thing among them, and that is the squared. And that makes them a quadratic equation. So in other words, when you say quadratic equation, it's not necessarily complete number of terms. It can be 1 term only, 2 terms, 3 terms, for as long as there is the exponent 2, the highest exponent supposed to be, then that qualifies to be a quadratic equation. Now, I have here 5 equations. Can you pick which of these 5 equations is a quadratic equation? You pick now. If you have chosen number 2, you are correct. How about the next one? It will be number 3, the third one. And then another one is number 5. Your number 1 is not quadratic equation because there is no squared. Obviously, this is called linear equation. In number 4, we do not have the squared here. Instead, the highest exponent is 3. And therefore, this is not quadratic, but instead, this is called cubic. In number 5, you don't see any square there. But if you simplify by multiplying the binomials, you get square there. That is 2x squared being the first term. Therefore, it qualifies to be a quadratic equation. Is it clear? Now, let's go into the forms of a quadratic equation. Take note that this is very useful in the next topics to come. Actually, there are 2 forms of quadratic equations. The first one is the standard form, which is ax squared plus bx plus c is equals to 0, where a, b, and c are constants. The second one is the vertex form, which is y is equals to a times the quantity of x negative h squared plus k, where a, h, and k are real numbers. Note that in our discussion for today, we will focus only on the standard form. The vertex form will be discussed in the next days. How do we transform a quadratic equation into its standard form? Let us see. In transforming a quadratic equation in its standard form, actually, that is a prerequisite to some lessons, such as if you are solving a quadratic equation by factoring. Also, if you are asked to identify the value of A, the B, and the C in the standard form. So, before you transform, what are those knowledge that you should know in order for you to do transforming quadratic equations in the correct method or in the correct way? Okay, let's try this. For example, transform 2x negative 4 equals x squared. Take note that the quadratic equation in the standard form is ax squared plus bx plus c. You have three terms there in the left side of the equation. Your first term should contain the squared, the second term contain the x, and the third term contain the constant. Therefore, if you arrange this in that format, in that arrangement, then it becomes x squared negative 2x positive 4 equals 0. How about number 2? If you arrange that in that manner, of course, your first term should be 7a squared, the second is 2a, and the last term is containing 5. The arrangement should look like this. Did you get it right? Okay, number 3. In number 3, you need to multiply them first. So how do you multiply them? You do it the way we do multiplying binomials in the past lessons, even in your grade 8 before. So how do we multiply? So we multiply in this way. Of course, we have 4x times 3x. Then you continue. Okay? After multiplication, you get this product. And that's equals to 0. So it's 12x squared positive 11x negative 15. In number 4, this is a little different. For you to simplify them, you need to cross multiply them. So you have to multiply 2x times x negative 1, the quantity of x negative 1, and should be equals to 5 times 2. And then if you try to arrange them in the standard form, you get 2x squared negative 2x negative 10 equals 0. Did you get it right? Okay. How about if I have 5x squared negative 3x positive 10 is equals to 0? What will be the value of A, of B, of C? We go back to your standard form. It's ax squared plus bx plus c is equals to 0. If you try to compare it with the given, you would see that your a is 5, your b is negative 3, and your c is 10. There, the values of your a, b, and c. Okay, how about 5x is equals to 2 negative 7x squared? So obviously, this is not in the standard form. So first, we transform this into the standard form, which is 7x squared positive 5x negative 2 equals 0. Take note that your negative 7x is preferably made positive because that's the first term. Of course, if you make that positive, the rest of the terms, the sign of them, are affected also. So take note of that. And then from there, it's very easy to see that your A is 7, your B is actually 5, and your C is negative 2. How about this one? Again, we simplify them by cross multiplication. So this is 3 times the quantity of 4x negative 2 and 2x times the quantity of x plus 1. As you see it there. By distributive property, I have 12x negative 6 equals 2x squared positive 2x. Just plain distributive property. We will now arrange them into the standard form. Take note that your x squared should be the first, followed by x, and the last, of course, is the constant term, and that should be equals to 0. And then if you arrange them in that manner, then that becomes 2x squared negative 10x positive 6 is equals to 0, for which we now get the values of a to be 2, your b is negative 10, and your c is 6. How do we solve quadratic equations? Okay. There are four known ways of solving quadratic equations. The first one is factoring. The second one is finding the square root. The third is completing the square. And the fourth is using the quadratic formula. But for today's lesson, we will focus only on factoring. The rest of these ways, finding the square root, completing the square, using the quadratic formula, will be discussed in the next days. Okay. How do we solve quadratic equation through factoring? Let's illustrate them this way. For example, I have 2x plus 3 is equals to 5. What would be the value of x to make the equation true? Can you think of a number that when you substitute it with x, the answer is equals to 5 actually? Have you thought of the number? You can do that mentally. Okay, if your answer is 1, then you are correct. Now let's try to substitute 1 as x, which is 2 times 1 plus 3 is equals to 5. Obviously, 2 times 1 is 2, so you have 2 plus 3 is equals to 5. Therefore, you get 5 is equals to 5. In other words, your 1, if your x is 1, then the equation becomes equal. Or, you can simply say, if x is equals to 1, the equation becomes true. In other words, you can also say in different ways, therefore, 1 is the solution set of the equation, or we say 1 is the root of the equation. Otherwise, we can also say 1 satisfies the given equation. Take note that we are now using the technical terms solution set and root. Actually, these two are the same. So if ever that number will make the equation equal, that number will make the equation true, that is what we call solution set or the root. How about this one? If x squared negative 4x negative 12 is equals to 0, what would be the root? So can you think of a number that when you replace it with x, it becomes equals to 0? Can you do it now? I don't think you can do it easily. Actually, a while ago, our equation then is linear, but this time it is now with the presence of squared. So, it's not as simple as it is. Okay? You cannot just think of a number that easy. Okay? How do we solve the equation now? So, let's start with our objective. For you to solve the equation, your objective is to solve for the value of x. Remember that. So, what is that number that will replace x? Let's start with grouping your left side. Now, your left side will now be factored. The factoring process was taught to you before. So, if ever you don't know how to factor out, go back and recall. Your x squared negative 4x is equals negative 12 is equals to 0 is factored as x negative 6, the quantity of x negative 6 times the quantity of x plus 2 equals 0. And then, each of these factors are equated with 0. So, it's x negative 6 equals 0 and x plus 2 is equals to 0. But the question is, which rule allows us to equate the factors to 0? We have the zero factor property. It says, if AB is equals to 0, then A is equals to 0, B is equals to 0, or both is equals to 0. It means to say that if you multiply two numbers together and the answer is 0, definitely one of them should be 0 or both of them are 0. Otherwise, if you multiply them but none of these two numbers is 0, you cannot have the answer 0. That is what it means. So, this particular property tells us that we can equate each of these factors to 0 because after all, the product of these two factors is 0. Just like here. Okay? So we suppose that your x negative 6 is A, your x plus 2 is B. Since they are equals to 0, then we can equate them to 0. If x negative 6 is 0, then obviously the value of x should be 6, right? And if x plus 2 is 0, the value of x should be negative 2. Therefore, the values we are looking for are x to be 6 and negative 2, which is what we are looking for. Now let's see if they are really the numbers we are looking for. If x is 6, our main equation or our original equation is x squared negative 4x negative 12 is 0. So if x is 6, if you replace that there, it becomes 6x, 6 is squared, negative 4 times 6, negative 12 is 0. So you have 36, negative 24, negative 12 is equals to 0. So you have negative 24 and negative 12 both negative. So we combine them together. So you have negative 36 there. So 36 minus 36 is 0. Therefore, 0 is equals to 0. We have proven that that value 6 will make the equation equal. Therefore, 6 is a correct value. Okay, how about negative 2? Again, we use the same equation. X squared negative 4x negative 12 is equals to 0. So we replace them there. So you have negative 2 squared, then minus 4 times negative 2, negative 12 is equals to 0. So you have negative 2 squared, that's 4. Then negative 4 times negative 2 is 8. Then minus 12 is equals to 0. 4 and 8 together are positive, so you can combine them together. That becomes 12. Minus 12 is equals to 0. Again, you have 0 is equals to 0. And we have proven that your x negative 2 is correct. In other words, the integers 6 and negative 2 are the roots of the quadratic equation. X squared, negative 4x, and negative 12. While, of course, the other way of saying it is the solution set or the integers or the set of 6 and negative 2 is the solution set of the quadratic equation x squared, negative 4x, negative 12 is equals to 0. Let us try to solve another quadratic equation. We have 6x squared negative 11x is equals to 10. Can you factor this right away? Of course not. Just like what I have said, we will first transform this into its general form or standard form. So our standard form will be 6x squared negative 11x negative 10 is equals to 0. So since this is now equals to 0, which is in standard form, we are now ready to factor out, which is 2x negative 5, the quantity of 2x negative 5 times the quantity of 3x positive 2. And we are now ready to equate each of these factors. 2x negative 5 equals to 0 and 3x plus 2 is equals to 0. Again, if you have 2x negative 5 is equals to 0, your x there should be 5 over 2. And your 3x positive 2 is equals to 0, your x there should be negative 2/3. That is by transposition or addition property of equality only, and of course division property. Just apply these two properties. The roots are of course 5 over 2 and negative 2/3. As simple as that. Let's have the summary of the lesson. So a quadratic equation is a polynomial equation with the highest exponent of 2. This can be said in different ways, but the meaning is the same. The forms of the quadratic equation are, the standard form is ax squared plus bx plus c is equals to 0, where your a, b, and c are constants. And the second one is the vertex form, which is y is equals to a times the quantity of x negative h squared plus k, where a, h, and k are constants. And in solving quadratic equations using factoring, we need to transform the equation into its standard form before we apply factoring on the left side of the equation. After finding the factors of the left side, we use the zero factor property to solve the value of the variable. Did you understand? Okay, so thank you very much and see you next time.